Alrighty, next step. The next step is to convert to convert from an RGB to an indexed image with an associated color map containing 8 colors. So let's go ahead and do that. You're gonna use, it tells you here, use RGB to end, right? Hang on, is that where I'm recording? Yes, it is. Alrighty, let's go back to matlab. I did it earlier, but I'll do it again. So the way RGB works is RGB to end works is it will return 2 parameters, just like up here. Sorry, up wherever. Up here. It's going to have an image and a map. So I'm going to call the image new image and the new map new map. And it's going to be equal to RGB to end. And I want to convert old image, and I want to have 8 different colors. So it'll take the old image and convert it to the new image, and it's going to choose the 8 most frequently occurring colors and reconstruct the image using only those 8 colors. So I ran this earlier, and here is what I came up with. Alright, old image, and here's the new image. So you can see this one's smooth, lots of different colors, and this one has a lot more pixelated because it's only using 8 colors to recreate the entire image. So that works pretty well. You can try it for other images and see what you come up with. So the next step will be saving the image using the function imwrite, which I will do now. So imwrite takes 3 parameters or 3 arguments: the image you want to save, the color map you want to use for the image, and where you want to save it. So imwrite, I want to save new image and new map, and I'll save it as new image.png. Cool. Alright, I'll do another image just to show you how it works. Let's use how many good images have I? Maybe this one back here. Alright, I'll use this one. Let's see how it went. So, new image is this guy. It's all kind of blurry and terrible looking, but that's because it only has 8 colors. And the original image is here. Yep, so you can pretty clearly see. This one's kind of alright, but this one's really blurry because it only has 8 different colors. So it worked. That's good. Now we need to calculate the probability of each color occurring. So first you need to understand how each color is saved before we can calculate it. So head back to MATLAB. Actually, I'm going to use a new image that illustrates this really well. Alright, so here's the image I used. It's a bunch of different colors. And the way MATLAB saves colors, or the way computers save RGB, what am I doing? The way computers save RGB is using 3 values between 0 and 255 for each saturation of color. So if I look at 8 new map, I've got 8 different colors here. And, sorry, I've opened another MATLAB. There we go. Okay, so here's my new map. This is the colors that the new image is using. And they're between 0 and 1, or 0 and 100%. So, for example, this color would represent a color which has 4% red, 5% blue, 5% green, sorry, and 2% blue, RGB. So there's not much color in this, or there's not much saturation in this color at all. So it's probably going to be a very light, very dark color, sorry, because black is just the absence of color, right? So let's have a look at this image. Hang on, what have I done? New map. That should be alright. Okay. New image. Let's print out this. New image 1. The very first pixel is 2. Now, does that make sense? Hopefully. So, If you look over here, there's between 0 and 7 in this new image array. So it starts from 0 and goes to 7. That's 8 different numbers for 8 different colors. So normally in matrices start from 1, but they've decided to start from 0 for whatever reason. That's alright. So the very first color is 2. But because it starts at 0, we're going to have 0, then 1, then 2. So 2 actually represents the third color in this new map. So if we're going 1, 2, 3, this is the color it's pointing to. So the very first pixel is whatever value this is in RGB. So it's going to have a large amount of red, 98% red, 0 blue, and 0 green, which makes sense. This very top pixel is all red, which as you can see is red. Let's check the very last pixel to confirm this. New map, new image. The last pixel, because I figured it out, is 125,440, which is the total amount of pixels in the image. It's 5. So that actually corresponds to the 6th value in here, because it starts from 0, not 1. So 1, 2, 3, 4, 5, 6. It's going to have 50% red, 0% green, and 100% blue. So using those colors, you get purple or violet, which makes sense because violet is mostly blue and a bit red. And as you can see, you construct all these different colors here. There's also, you can see we've got this color here, which has not got much color at all. That's probably going to be black, which is the letters here. So there's a bit of black in this image as well. Alright, so hopefully that makes sense. You can see which color is represented. So if you print out this entire array, new map, you're going to get, new image, sorry, you're going to get like 1 billion numbers, which is all the numbers. And each time it sees a 5, it's going to put purple or whatever color corresponds. So this is the end of it. There's heaps of 5s, which makes sense because there's going to be lots of purple pixels towards the end of the image. So now that we know how it saves pixels, we can go ahead and figure out the odds of each pixel occurring.